Math 3, Unit 1, Section 6. Today we're going to talk about piecewise-defined functions. So yesterday we did a piece of a graph. Do you guys remember that? So we had our restrictions and we only did parts of a graph. Today we're going to do like 2 parts on one graph. So where our highlighted lines are, there's going to be a certain graph in one area and then a different one in the other. So that's what it's saying right here. So our domain tells us what the graph is that goes in each of the sections. So if you missed yesterday, basically today's concept is building on it, so you'll probably be okay, I think. First thing, it says evaluate. So on this one, we actually don't have to graph. It says f of x are these 2 equations. So it's x squared minus 4 if x is less than -1, and it's 3 to the x plus 1 if x is greater than or equal to -1. So if you look up here, and what I like to do is just label these, like this is equation 1, this is equation 2. F of 0, is that value less than -1 or is it greater than or equal to -1? Is 0 less than -1 or is 0 greater than or equal to -1? Good. So that means we're going to use which equation? The second one. We're going to use equation 2 because since this value is 0, 0 is greater than -1. Okay? We're going to plug in 0 for x in this equation. 3 to the 0 plus 1 equals 3 to the first, which is 3. As an ordered pair, this makes the ordered pair 0, 3. Do we have confusion on this? Do we understand why we chose the second equation? Yeah? And then all we're doing is plugging it in and solving. That's all we have to do here. Okay, -3. Is -3 going to be with equation 1 or 2? It's going to be equation 1. -3 is less than -1, so we're going to use equation 1. So we're going to plug in -3 into this equation and solve. We get -3 squared minus 4. What is -3 squared? 9. And 9 minus 4 is 5, and so this ordered pair is -3, 5. Okay, and -1, which equation will that go with? Why is it going with 2? Because both of them have a -1. Because it's the one that has the equal to with it, okay? So that is equation 2. We have 3 to the -1 plus 1, and what is -1 plus 1? 0. 3 to the 0 equals 1, and so this ordered pair is -1, 1. All right, are we ready for the next one? So this one has different restrictions. Remember that when it's written like this, it means all values between -1 and 2. And this is saying all values between 2 and 4. Okay, also notice that this one has the equal sign with the 2, and this one does not have the equal sign with the 2. So pay attention to where the equal signs are. Again, we'll label these as equation 1 and equation 2. So 0. 0 is going to fit with which equation? Very good. The first one is correct. Now, is there, in this first equation, is there an x here for me to plug into? No. So guess what the answer is? 7. Okay, and as an ordered pair, that would make 0, 7. Remember, that's going to just make a straight line. Okay, a straight horizontal line. Okay, 2. 2 is going to go with which equation? Very good, the first one. And again, pay attention to where the equal sign is, because even though there are 2's for both of these, The equal sign is with the first equation, which is why the 2 is going to go with the first equation and not the second. Okay, and what would be the answer for that? 7, very good. And as an ordered pair, that would be 2, 7. Do we have questions? Okay, 4. Which equation will 4 go with? Very good, the second one. We're going to go ahead and plug that in. And so that is 5 minus 3, absolute value of 4 minus 1. You need to do absolute values first. Absolute values are like parentheses, and you simplify inside and take care of that first. What is 4 minus 1? 3, good. Okay, and so then I have 5 minus 3, and what is the absolute value of 3? 3. And these side by side mean multiply, so 3 times 3 is? Did I do something wrong? So going back up here, let's just double check. So we wrote this out, 5 minus 3, absolute value, we're plugging in 4, right? Minus 1, 4 minus 1 is 3. Absolute value of 3 is 3. And then we multiply 3 times 3, which is 9. And so we have 5 minus 9, which is? Negative 4. Are we okay? All right, so that ordered pair is good, 4, negative 4. Okay, negative 1. What's going to happen at negative 1? So what do you do? Because this one doesn't have the equal to sign. But if we were doing this restriction, would we still need to figure out what's happening at negative 1? And then what would we do at that point? Very good. So this would make an open circle, but we still need to figure out what the value is there, even though it doesn't have the equal sign. Okay? And so we would use equation 1, which means what would be the answer for g of negative 1? 7. Good. And so that ordered pair would be negative 1, 7, and we would just have an open circle. And what about g of 5? Where does that fit? Yeah, it doesn't fit anywhere. So this one is just like a no solution. And we would write not within the domain. Or you could say it's not on the graph or something to that effect. Okay, any questions? So we're going to start using our graph and figuring all this stuff out. So on this next question, it says graph the following, show significant points, and then we'll state the domain and range using interval and inequality notation. I noticed on some of your quizzes, actually a lot of them, inequality, remember that inequality is when you're using the less than and greater than signs, and intervals are where you're using like your parentheses and your brackets. Okay, so that's interval, and this is your inequality. Okay. All right. So we have two equations. Again, I would always label these as 1 and 2, so it's very easy to go and find your work if you made a mistake or to see what's going on. After you label those, the next thing I would do is figure out your domain restrictions. So what line am I going to need to highlight for this graph? Just 3. Okay, so this one is where x is less than or equal to 3, and this graph is where x is greater than 3. Are we good? Okay, so over here, this is going to be equation 1. Over here, this is going to be equation 2. All right, you guys ready to start with equation 1? Okay, so equation 1 is negative 1/3 x plus 2. What type of graph is that? It is linear. For that linear graph, what is my starting point? 0, 0, 2. So remember here, there's nothing in parentheses with the x, which is where that 0 came from. And then the part that's adding at the end is where the 2 came from. Yes? Okay, now we can either plug in a point or we can use our slope. What do you guys want to do? Slope. And so my slope on this one is negative 1/3. So we'll plot our point, 0, up, 1, 2. And my slope is negative 1/3. So down 1, right 1, 2, 3. And I notice I'm on my highlighted line. For this graph, on my highlighted line, is it supposed to be an open or a closed circle at that point? Closed. If I didn't end up on my highlighted line, you need to figure out what's happening there, and we could have plugged in the value of 3 and figured out what the answer was. Okay? And then you can also remember, you can go up 1 and left 3. And then we can draw our line, or you could have just had those 2 points. It's fine either way. And the line is only to the left, and so that's why I only have an arrow going in that left direction, because on this side of the graph is this line. Okay. So now we're going to do the other side. I'm going to do a different color for the other side just so we're able to kind of see it better. So on the other side of the graph, and I could have actually written this line as y equals this negative 1/3. When you have the 4, this is just saying y equals 4, which we know is also a what? It's a line, right? A horizontal line. And where is it going to be at? Where do I go to make that horizontal line? Good, 4 on the y-axis. So we go up 1, 2, 3, 4. And at that value, is it going to be open or closed? Open, because it doesn't have an equal to sign. And it's a straight line, but it's only going to the right. So normally y equals 4 would be like a line going all the way through there, but because of the restrictions, it's only taking the piece to the right of it. Do we have any questions with what we've done? Go okay? If you have questions, I'll take them. Okay, so let's state the domain and range then. I'm going to move this up. Is that okay? All right, so looking at the graph, going from left to right, starting at the left, that makes what? Negative infinity. And as we go along, we go. I notice here that there's an open circle, but do you see that there's also a closed circle? Yes? So that means we're good. We only have to worry about when there's like an open circle and nothing else is filling it in somewhere else. Okay, so we can just keep going, and then we get to that arrow. So that means my domain goes to positive infinity. For the range, what is my smallest range value? 1, parenthesis or bracket? Bracket, 1. And then we go up, and there's an open circle here, but do you see how there's still a line over on the other side? So that means we're good, right? And then we keep going, and there's an arrow, which means it goes to positive infinity. Okay, so I just wrote this in interval notation. We also need to write it in inequality notation. So what does this look like for the domain in inequality notation? negative infinity less than x is less than positive infinity. I notice on some of your quizzes, those of you that were using inequality form, you put equal to. When you put the equal to underneath, that means that these are brackets and there's an actual endpoint. Does infinity actually end? No. So make sure you do not have an equal to sign underneath here. Okay? This one is going to be what? For the range. 1 less than or equal to y is less than infinity. And because that's a bracket, we use the equal to sign. Any questions? Yes? Oh, because it's still the same graph. So we're taking the domain and range of like this whole graph. So this graph, there's two pieces of it, and so it's called a piecewise function. So you have a piece and a piece, but they're all still on the same graph, and so the domain and range is coming from that graph. Any other questions? Okay, we're just going to do one more example for today, and then we'll stop. All right? Okay. So again, let's go ahead and label this. We are going to have equation 1 and equation 2. What line am I going to highlight on this graph? Very good, 0. So we're going to go down here. We're going to highlight at 0. Equation 1, is it going to be on the left or the right of the highlighted line? Left, less than 0 is on the left, and greater than or equal to 0 is on the right. So we're going to start here with equation 1, and I'm going to rewrite that equation. Y equals negative absolute value of x plus 2. The fact that it has an absolute value tells me that it's what type of graph? Linear absolute value. Good. Linear absolute values, we actually have a vertex, correct? And my vertex is where for this? Good. There's another thing you should be aware of, and that is that you have a negative out in front, which means that the graph should end up facing which direction? Down. Some of you on your quizzes, it had a negative in front, and you had your graph going up, or vice versa. They had like a positive, but you had it going down. So always double check that your graph makes sense once you do it. Okay, so negative 2, 0. It's not on my highlighted line, so I'm going to go ahead and make my point there for my vertex at negative 2, 0. Now with linear absolute value, because it is linear, we can use what? The slope. Or we can plug in a point. So it's up to you. For right now, on this one, I'm going to go ahead and plug in a point because I want to know what's happening to this graph when x is actually at 0. Okay, so I'm going to plug in a point. I'm going to put point here because I'm making a point, and I'm going to plug in 0 for the x, and I need to figure out what is that y value. Okay? And again, I plugged in 0 because I want to see what's happening with this graph there. So we have negative absolute value of 0 plus 2. What is 0 plus 2? 2. And so, and the absolute value of 2 is 2, and then there's a negative in front. So that point is at 0, negative 2. Now, is it open or closed there? Open. Because on my graph 1, at the 0, it's open. And then remember, it's symmetrical. So this is 2 away from the vertex in this direction. So I'm going to go 2 away in the other direction. And then remember, the highlighted line is what's stopping that graph. Here, you want me to move that up for a second? And so when you're drawing this graph, these connect and you have your arrow, and then it stops at that line for that graph. Do we have questions? Are we okay? You guys ready for the next one? Okay. So second equation. What type of graph is this going to make? Good, it's quadratic or parabola. So that means I have a vertex. What is my vertex? Is there anything in parentheses with the square term? Nope. So that part is 0. And then the part that's at the end is your y value, which in this case is going to be -2. Are we okay with that? All right. So 0, -2. If I go down to my graph, 0, -2, it's at that same point. Okay? But on this one, is it supposed to be open or closed? Closed. So we're going to fill this in. It just happens that it's at the same point. Sometimes they're at the same point, sometimes they're not. Okay? Also, this is my vertex. So that you don't get confused, I might mark this as the vertex so I remember that that's like the symmetrical part. And so I need a value to the right of that. We could choose 1, we could choose 2, it's up to you. I'm going to go ahead and just choose 1. Okay, and so for my point here, we're going to choose 1 for x, and then we need to figure out what the y is. So in the equation, we would have 1 squared minus 2. 1 squared is 1, and 1 minus 2 is -1. And so that ordered pair is at 1, -1. And it would be symmetrical across, right? But that goes into the restricted area, so I'm not going to do that. And then I know that this is curving up, like that. Do we have questions? Okay, so we have to do our domain and range. Are you ready for the domain and range? Can I push this up now? Are we good? Yes? Okay. All right, so starting on the left, what is the smallest value for the domain? -infinity. And we go along and it goes till +infinity. Correct? Okay, smallest value. If you notice there's an arrow there, which means -infinity for the range. And then we go up and up and up. And we notice there's another arrow, +infinity. And then in interval notation, -infinity is less than x is less than +infinity. And for the range, -infinity is less than y is less than +infinity. Do we have questions?